Hi friends, hi students. Okay, this is Sridhar's Chemistry Logics. So, today our topic is formal charge. So, in chemical bonding, another topic for you, formal charge. Okay, if you feel the content, please like and share, subscribe to my channel. Okay, thank you. Okay, first come to see formal charge here. So, what is the meaning of a formal charge? So formal charge means actually it is not a real charge. Of course, it is may or may not be a real charge of ion or atom. That means this is just hypothetical charge. So what is the definition here? Formal charge means it may be assumed the charge of an atom in a molecule in which all atoms are having almost same electronegativity. So the charge present on an atom in a molecule when all the atoms are having almost same electronegativity. So it is hypothetical charge. It may or may not be a real charge. So how to calculate formal charge for any atom in a molecule? Okay, now children. So see here students, the formal charge QF equals to, formula is number of valence electrons minus number of lone pair of electrons minus half into number of bond pair of electrons. Okay, now students, so see here, formal charge formula is number of valence electrons present in an atom minus number of lone pair of electrons minus half into number of bond pair of electrons. Another easy formula also there. What is the formula? Number of valence electrons in isolated atom minus number of electrons assigned to that atom in Lewis dot structure. So like this we can calculate formal charge. So students listen here, another time I will repeat the formula. Number of valence electrons in isolated atom minus number of electrons assigned to that atom in Lewis dot structure. So any formula we can use. Okay, first we consider the molecule pH3. So in phosphine, let us calculate phosphorus formal charge. Before going to calculate formal charge, we should draw the Lewis dot structure for pH3 molecule. So we know that phosphorus is having a lone pair of electrons and three bond pairs are present with hydrogen atoms. So by using the first formula, formal charge of phosphorus is number of valence electrons. As phosphorus belongs to fifth A group, it has 5 valence electrons. So 5 minus, and here number of lone pair of electrons 2. So many students will take it as 1. But in the formula, this NLP indicating the number of lone pair of electrons. That means if one lone pair is there, the number of lone pair of electrons, how many? 2. 5 minus 2 minus half into 3 bond pairs are present. Means 3 2s are 6 electrons. So now 5 minus 5, what we can get formal charge? 0. Otherwise, use the second formula, the trick to valence, that to calculate that formal charge. Now here, QF equals to, come to the phosphorus, number of valence electrons. Number of valence electrons, how many? You know that 5. 5 minus Now in the phosphine-Lewis dot structure, this lone pair belongs to phosphorus, and in this bond pair, one electron belongs to phosphorus, one electron belongs to hydrogen. In the second bond, in the third bond also same way. That means one electron belongs to phosphorus. So these two electrons, and out of the six electrons, three electrons belong to phosphorus. So these three electrons plus two electrons, five electrons. So in the Lewis dot structure, number of electrons belongs to phosphorus. How many? Here 5. So 5 minus 5, you can get 0. Now another example you may observe here, ozone. We have to draw the Lewis dot structure of ozone. Let it be the first oxygen atom. This is second oxygen atom. This is third oxygen atom. Now the center oxygen, that means the second oxygen atom, donate a lone pair of electrons to third oxygen atom, forming a dative bond. So by using our trick, the second formula, let us calculate formal charge of first oxygen. You know that oxygen belongs to 6th A group. So number of valence electrons present in oxygen, how many means 6. 6 valence electrons are present. Now come to the number of electrons assigned to this oxygen, number of electrons assigned to this oxygen in ozone structure. See here, these two electrons belongs to this first oxygen, and here a double bond is there. Double bond means two electrons are belongs to this oxygen. So 2 plus 2 4, 4 plus 2 6. So the number of electrons belongs to this first oxygen in this Lewis dot structure 6. So 6 minus 6 equals to 0. So formal charge of first oxygen atom in ozone molecule is 0. So let us calculate the formal charge of second oxygen. See here again, second oxygen valence electrons are 6, and come to here, this second oxygen, a lone pair means 2 electrons. Here 2 bonds means again 2 electrons, so 4, and in this bond 1 electron belong to oxygen. So that means here 2 plus 2 4, 4 plus 1 5. So therefore 6 minus 5, the formal charge of second oxygen atom is plus 1. And third oxygen atom, now here again, the number of valence electrons in isolated oxygen atom 6 minus, now 2 plus 2 plus 2, 3 lone pair of electrons means these 6 electrons, and in this bond 1 electron belong to oxygen. 6 plus 1 7, that means here 6 minus 7. The formal charge of this oxygen is minus 1. Another simple formula also you may know here. What is that? If you come to the first oxygen in ozone, actually 60A group elements that contains total 2 lone pairs and 2 unpaired electrons in that valency shell. What is the configuration? NS2NP4. So 2 lone pairs. This oxygen is having 2 lone pairs, and by using that 2 unpaired electrons, oxygen can form 2 bonds. That means this first oxygen is having total 6 electrons with itself only, neither losing nor gaining the electron. If any element neither loses nor gains electron, now what is the oxidation state? 0. So that's why here formal charge of first oxygen is 0. Now come to the second oxygen. You know that second oxygen means actually again it has to it has contain two lone pairs and two unpaired electrons. So by using two unpaired electrons, two bonds are formed. But out of the two lone pairs, one lone pair of electron only appearing on this oxygen. But another lone pair is present in sharing. That means out of the two electrons, that means one lone pair means in that two electrons are present. In that one electron only belongs to this oxygen because sharing. So that means here this oxygen has one electron less because out of the two lone pairs and two unpaired electrons. Total it has to possess how many electrons? So 6 electrons. But here 1, 2, 3, 4. In this only one electron belongs to this oxygen. 5 electrons present near to the second oxygen. Means it lost one electron. So if any atom loses one electron, you know that it will get to plus 1 charge. So the second oxygen atom formal charge is nothing but here plus 1. And come to the third oxygen atom here. This third oxygen atom, count the number of electrons, 2 plus 2 plus 2, 6 electrons. And in this one electron belong to third oxygen. Means it has a total 7 electrons. So now here, if any atom gain one electron, you know that it will get which charge here? Minus 1 charge. So that's why only the third oxygen formal charge is minus 1. So using any formula you can calculate here. So the simplest formula is number of valence electrons present in isolated atom minus number of electrons assigned to that atom in molecule by using Lewis dot structure. Okay, let us go for another example. Nitrous oxide N2O. So we can calculate formal charge of two nitrogen atoms and one oxygen atom. So now here N2O, we need to draw the Lewis dot structure of N2O. Nitrogen belongs to 50A group element. That means 50A group. It has total 5 valence electrons and configuration is Ns2np3. So total 5 valence electrons are present. And we need to draw the Lewis dot structure here. Now here double bond, here also one double bond O. Oxygen is having two lone pair of electrons. So this is one structure belongs to N2O. By using this formula, formal charge of first nitrogen, formal charge of first nitrogen. Nitrogen number of electrons in valence shell 5 electrons, and in this these two electrons belongs to this nitrogen. So therefore, and after that in this double bond two electrons belongs to, in this double bond two electrons belongs to nitrogen. So 2 plus 2 4, 4 plus 2 6, 5 minus 6. So the formal charge of first nitrogen atom is minus 1. Next come to QFN2, second nitrogen atom. The number of valence electrons 5 minus, now in this Lewis dot structure, 1, 2, 3, 4. 4 electrons belongs to that central nitrogen. Now 5 minus 1, 5 minus 4 means plus 1. So the nitrogen, second nitrogen formal charge is plus 1. And try to calculate formal charge of oxygen. So oxygen number of valence electrons 6, and here 2 plus 2 4. In these two bonds 2 electrons belongs to oxygen. So 2 plus 2 plus 2 6. 6 minus 6 means 0. So like that here number of valence electrons 6 and assigned electrons also 6. Therefore The formal charge of that oxygen is how much means 0. So like this we have to calculate formal charge of any neutral species using any of these two formula. First one is number of valence electrons minus number of lone pair of electrons minus half into number of bond pair of electrons. And another easy formula, number of valence electrons in isolated atom minus number of electrons assigned to atom in the Lewis dot structure. So now we calculate formal charge for ions. This is regarding molecules. Then the second one is here, calculation of formal charge in ions. So now come to the SO4 minus 2. The question is here, what is the formal charge of oxygen? What is the formal charge of oxygen? So we have to draw the structure of SO4 minus 2. This is the structure related to which one here? SO4 minus 2. But we know that we can write somewhat resonance structures here. Sometime this pi bond will migrate to this oxygen, minus charge attained by this oxygen. Here also this pi bond migrate to this oxygen, minus charge is attained by this oxygen. That means here the minus 2 charge is shared by 4 atoms in this SO4 minus 2. That means the simplest formula for formal charge is total charge present on the species divided by number of bonded atoms. Number of bonded atoms. Because this charge is not gained by, not attained by the central sulfur. Only this minus 2 charge shared by the bonded atoms. So that's why only number of bonded atoms. So total charge is minus 2 and it surrounded by, that is it is migrating among the 4 oxygen atoms. So minus 2 by 4 means minus 1 by 2, minus 0.5. This is the formal charge of oxygen present in SO4 minus 2 molecule. Similarly, in NO3 minus, in NO3 minus, nitrogen is a central atom and it is bonded with 3 oxygen. That means 3 oxygen atoms. In that one oxygen atom is having minus charge. So that means here bonded atoms, how many means 3 bonded atoms. So NO3 minus. Therefore formal charge of oxygen is, formal charge of oxygen is minus 1 by 3. Because minus 1 charge is shared by 3 oxygen atoms. That is migrating among 3 oxygen atoms. So like that here, formal charge of oxygen in NO3 minus is how much means minus 1 by 3. Okay, these are the methods to calculate formal charge. Okay, in the next video we can met with dipole moment and calculation of dipole moment. Okay, bye, thank you.